Good morning, friends. Today I'm going to start with the next chapter, that is electrochemistry. We have already finished with the chapter solutions, numericals, etc., the theoretical questions which I gave you yesterday. I'm going to start with the chapter today. The date is 24th April 2020, and I'm going to start with the chapter electrochemistry. First of all, what do we mean by the word electrochemistry? Electrochemistry is actually that branch of chemistry which mainly deals with two types of energies. Number one is chemical energy, and number two is electrical energy. It mainly deals with conversion of electrical energy into chemical energy and chemical energy into electrical energy. So any branch of chemistry which mainly deals with these types of conversions, that is conversion of electrical energy into chemical energy or conversion of a chemical energy into electrical energy, comes under the chapter electrochemistry. There are two types of cells which you have already studied in class 11 a little bit. Number one, there are electrolytic cells, and number two, there are electrochemical cells. Any electrolytic cell will convert electrical energy into chemical energy, but an electrochemical cell is opposite. It converts chemical energies into electrical energy. We will deal them one by one, that is electrochemical cells as well as electrolytic cells. I am starting with electrolytic cell. In any electrolytic cell, if we talk about basic assembly, which we already know, it consists of a container. There must be a container, and in that container there are two electrodes. One is negatively charged, which is cathode, another is positively charged, which is anode. The two are connected with the help of a battery, and we need to take inside this container, we need to take certain electrolyte. We know that what is an electrolyte? An electrolyte is a substance which allows electric current to flow through it and undergoes decomposition. That is, if you take sodium chloride as an electrolyte, sodium chloride, when electricity passes through sodium chloride, it breaks down into sodium ions and chloride ions. So what is an electrolyte? Electrolyte is that chemical substance which allows the electric current to flow through it, and it during that process it undergoes decomposition. So in any electrolytic cell, which we already know consists of a container. Inside the container there is a one electrode which is negatively charged called cathode, another electrode which is positively charged which is called anode, and the two are connected to each other with the help of a battery. And we need to take certain electrolyte in this. The electrolyte which we take must be any ionic compound in the molten state or in the aqueous state. We know that any ionic compound is not a very good conductor of electric current in the solid state, because in the solid state all the ions are very tightly attached to each other and they are not able to conduct the electric current. So if you want any ionic solid to conduct electric current, to behave like an electrolyte, we either take its aqueous solution, because when we add water to it, it breaks down into its ions, or number two, we take it in a molten state, because in the molten state also it will break down into sodium and chloride ions, or it will break down into its ions. We cannot take that electrolyte, in the solid state, because in the solid state that electrolyte will not conduct electric current. This is an assembly of which you already know of a electrolytic cell. What clearly you can see, it consists of a negatively charged electrode which is called cathode, a positively charged electrode which is anode. I've taken an electrolyte and they are connected with the help of a battery. Now when we pass electric current through it, suppose I'm taking the electrolytes as sodium chloride only, I've taken molten sodium chloride, it will break down into its ions, sodium ions and chloride ions. Sodium ions being positive will start moving towards the negative electrode, that is cathode. Chloride ions being negative will start moving towards the positive electrode, that is anode. And when these ions move towards their respective electrodes, negative ions towards the cathode, positive ions towards the anode, they discharge their charge, that is they become neutral. A positive ion, when will it become neutral? By accepting electrons. And when will a negative ion become neutral? By removing electrons. So if sodium chloride is passed through electric current, sodium ion will move towards cathode and they will change into sodium metal. Sodium metal will get deposited at the cathode. and chloride ions will move towards the anode, and at these anode, chloride ions will lose electrons, oxidation will take place. At cathode, reduction will take place by gain of electrons, and at anode, oxidation will take place by loss of electrons, and chlorine gas will be produced. So in this next section, we have to study, like in CBSE, one common question which is being asked is, what are the products of electrolysis of the following? Like I tell you, molten sodium chloride. Number 2, aqueous sodium chloride, molten lead bromide. So you have to tell what will be the products after electrolysis, what will be the products which will be formed at cathode and at anode. Now, if we take molten substances, suppose I take molten sodium chloride and another cell I take aqueous sodium chloride, you will see that the products which are formed in both the cases will be different. The products at cathode and anode may not be same if we are taking different. So now I am going to tell one by one what will be the products which will be formed if I take, say, molten sodium chloride. I just now see molten sodium chloride. If you take, it will give you sodium ions and chloride ions. Sodium ions will move towards the cathode. They will gain electron, change into sodium metal. Chloride ions, being negative, will start moving towards the anode. At anode, they undergo oxidation, that is loss of electrons, and they change into chlorine gas. This was when we take molten sodium chloride. Now suppose we take, instead of taking molten sodium chloride, in the second case, if you see this, I have taken aqueous sodium chloride. I have taken aqueous sodium chloride. If you take aqueous sodium chloride, so sodium chloride will break down into sodium ions and chloride ions. But what about water which is present? Water also breaks down into H ions and OH ions. Here you can very clearly see sodium chloride breaks down into sodium ions and chloride ions. Water also breaks down into H ions and OH ions. Now both sodium ions are also positive and H ions are also positive. Both will start moving towards the cathode. When we were taking molten sodium chloride, only sodium ions were present and they move towards the cathode. But when we are taking aqueous sodium chloride, both sodium ions and H ions will move towards the cathode. Now there will be a competition because there are two ions which are moving towards the cathode. Now we have to remember, out of the two ions, those ions which have lower discharge potential, that is lower, since here we are talking about reduction, we will talk about lower reduction potential, that will undergo reduction and the other ion will remain as it is in the solution. मतलब दोनों ions में से दोनों तो discharge हो नहीं सकते, दोनों तो reduce नहीं हो सकते, तो any one ion जिसका भी discharge potential कम है, that will be getting discharged and the other ion will remain in the solution. For example, both anions I have given in this note, they will start moving towards the cathode. Now since the discharge potential of hydrogen ions is less than sodium ions, so what will happen? Sodium ions will remain in the solution, they will not get discharged, but जो hydrogen ions हैं, they will gain 2 electrons. You can clearly see hydrogen ions will gain 2 electrons and change into hydrogen gas. यही अगर molten sodium chloride था तो sodium ions were produced at cathode. Now in this case, hydrogen gas is being produced at cathode. ठीक? Let's talk about anode. Now at anode, if you clearly see, there are two ions. One is chloride ions, another are OH ions. Both chloride ions and OH ions will move towards the anode. Out of chloride ions and OH ions, chloride ions have lower potential. Hence, chloride ions will get oxidized and they will change into chlorine gas. So, what will be the products at electrolysis? When we were talking about molten sodium chloride, sodium was being produced at cathode and chlorine gas was being produced at anode. But when we are talking about aqueous sodium chloride, sodium ions are not being discharged. It is hydrogen gas which is being produced at cathode and chlorine gas is being produced at anode. Okay? Let's come to the second case, molten lead bromide. Suppose we take molten lead bromide. Lead bromide will break down into lead ions and bromide ions. Lead ions, क्योंकि ये molten है, so there is no water. There will be no competitive electrolysis here. Only lead ions will and bromide ions will move towards respective cathode and anode. Lead ions will get discharged at cathode and bromide ions will get discharged. So lead will be deposited at cathode and bromine gas will be produced at anode. Next which I have taken is acidulated water. That means water is a covalent compound. Water will not produce ions. In order that water produces ions, we will have to add certain amount of acid to it. I have added sulfuric acid to it. So if you take water and sulfuric acid, both ionize as water ionizes as H ions and OH ions. Sulfuric acid will ionize into H ions and sulfate ions. Now what will happen at cathode? Both H ions, दोनों में ही H ions है, तो there is no competitive electrolysis. Hydrogen ions will get discharged and what will be produced? Hydrogen gas will be produced. क्योंकि यहाँ कोई competitive electrolysis नहीं है, same ions है moving towards the cathode. Now let's talk about anode. If you see anode, there will be two ions. One will be OH ions जो water से produce हुए और sulfate ions जो किससे produce हुए? Sulfuric acid से. Both sulfate ions and OH ions will move towards anode. अब सल्फेट आयंस का डिस्चार्ज पोटेंशियल ज़्यादा है, मोर है as compared to OH ions. So OH ions will get discharged, OH ions will get oxidized and sulfate ions will remain in the solution. Now how the OH ions get discharged? 4 OH ions, if you see clearly, 4 OH ions will lose 4 electrons, 2 moles of water and 1 mole of oxygen. So what are the product of electrolysis? Hydrogen gas is being produced at cathode and oxygen gas is being produced at anode. Okay, next topic, let's take aqueous copper sulfate using platinum electrodes, using inert electrodes. You will see if we carry out the electrolysis of aqueous copper sulfate using inert electrodes, the products will be different, and using copper electrodes, the products will be different. For example, if we carry on the electrolysis of silver nitrate using inert electrodes, the products which are produced at cathode and anode will be different. But if we carry on the electrolysis of silver nitrate using silver electrodes, the products will be different. In your question in the CBSE, if such type of a question is asked, they will clearly mention what will be the product of electrolysis of silver nitrate using silver electrodes. What will be the product of silver nitrate using inert electrodes? They may use the word inert electrodes or they may use the word platinum electrodes. So let's take a look at aqueous copper sulfate. Suppose we are taking aqueous copper sulfate. You know copper sulfate will break down into copper ions and sulfate ions. And since we are taking water, water will also break down into H ions and OH ions. Both copper ions and H ions will start moving towards the cathode. Now copper ions and H ions, out of copper ions and H ions, copper ions have got lower discharge potential. So H ions will remain in the solution and copper ions will get discharged. So copper will get deposited at the cathode. Now, what about anode? Now at anode, both sulfate ions and OH ions will move. Just now we have talked about in acidulated water, if both sulfate ions and OH ions move towards the respective electrode, here they will move towards the anode. सल्फेट आयंस का डिस्चार्ज पोटेंशियल ज़्यादा है, OH आयंस का डिस्चार्ज पोटेंशियल कम है, तो OH आयंस will get discharged. Again 4 OH ions will lose 4 electrons, and 2 moles of water will be formed, and what will be formed? 1 mole of oxygen will be formed. So what are the products of electrolysis? Copper is being deposited at cathode and oxygen gas is being released at anode. Next, let's talk about electrolysis of copper sulfate using copper electrodes. Up till now we were talking about electrolysis of copper sulfate using inert electrodes or using platinum. Suppose we are carrying on the electrolysis of copper sulfate using using copper electrodes. So aqueous copper sulfate hai, both copper ions and H ions will move towards the cathode. We have talked just now, copper ions will get discharged, H ions will remain in the solution. So the product here will be again copper will be deposited at the cathode. What about anode? At anode, OH ions will also move and sulfate ions will move towards the anode, but no one will be discharged. क्योंकि हमारा एनोड किस चीज़ का बना है, कॉपर का ही बना है, तो कॉपर का ही एनोड वो ऑक्सीडाइज हो जाएगा. ये जो दोनों आयंस हैं वो सोल्यूशन में ही रह जाएंगे, दे विल नॉट गेट डिस्चार्ज. एंड कॉपर, जो कॉपर का इलेक्ट्रोड है, दैट विल अंडरगो ऑक्सीडेशन. देखो बहुत क्लियरली आई हैव रिटन, कॉपर, जो कौन सा कॉपर, जो एनोड का कॉपर है, अंडरगोज इलेक्ट्रोलिसिस टू गिव यू कॉपर आयंस. एंड तो एनोड पे कॉपर ऑक्सीडाइज हो जाएगा और कैथोड पे कॉपर रिड्यूस हो जाएगा. जो बाकी आयंस हैं दे विल रिमेन इन द सॉल्यूशन. In exams, how will the question be asked? In your NCRT book, on the last page of this book, there is a particular question related to this. What will be the product of electrolysis of the following? So you will have to write down the way I have written. Suppose it is molten sodium chloride, we will write down it. Molten sodium chloride will break down into sodium ions and chloride ions. Sodium ions will move towards the cathode. At cathode, sodium ions will, then you have to write down the equations concerned. This was your first part of the chapter. Next part is Faraday's laws of electrolysis. We are talking about electrolytic cells. Next topic I'll cover in my next video, that is Faraday's laws of electrolysis.